The next topic is concurrency control. And that's a very important concept for multi-user databases. The problem in the multi-user database environment is that sometimes you may have multiple users simultaneously accessing the data and try to update the data at the same time. So how do you resolve this issue? Well, let's first take a look at the problem. In this example, let's say John and Marsha, both of them are trying to access their bank account using the ATM card in two different ATM machines. Let's say they have a joint account. John puts the ATM card into the machine and reads the account balance to be $1,000. And at about the same time, Marsha also does the same thing and puts the card into ATM machine and also reads $1,000. John withdrew $200, so the balance of $800 is applied to the account. And then at the same time, Marsha withdrew $300, so the balance becomes $700 from that $1,000, and $700 is applied to the account. So you end up with $700 in the account. However, actually these two people together withdrew $500. You should really only have $500 in the account. So that's the problem with concurrency control. Like when you have multiple people accessing and updating the database simultaneously, then the data can be inconsistent. How do you control the concurrency? Well, the most important technique is serializability. It basically means we only allow one transaction to be finished at one time, and the other transaction cannot start until the first transaction is finished. So how do we ensure that the second transaction cannot start? Well, we can use what's called the locking mechanism. When we lock a record, well, it depends on what kind of lock we are going to use. If we are using a shared lock, then the other users can view the record but cannot update the record. And if we use an exclusive lock, what will happen is the user will not be able to update the record and will not be able to view the record as well. That's the locking mechanism. So using the locking mechanism, this is what's going to happen. John puts the card into the ATM machine and requests the balance, and then looks at the balance, which is $1,000. And at the same time, Marsha also puts the card in the ATM machine. However, request is denied because the data is being accessed by another user. So John gets to withdraw $200, so $800 is applied to the account balance. And then once John finishes his transaction, then Marsha's transaction can start because the lock is released. So Marsha is able to read the balance, and now it's $800. And then with just $300, you end up with $500. So that solves the problem. By the way, you can lock the database at different levels. You can lock it at the field level, record level, table level, or database level. Depends on how much data you want to lock during the concurrency control. There are two types of locks. One is a shared lock. Shared lock allows other people to read the record but not update the record. An exclusive lock does not give access to other users at all. So if we are using the shared lock, John reads the database, and John is going to put a shared lock on the data so that Marsha can read the data but cannot update the data. John checks the balance. At the same time, Marsha decides to read the balance. When Marsha reads the balance, she also puts a shared lock on the database. So John will not be able to update the database, but only be able to read it. Then John will request the write, and it will be denied. And Marsha will also try to request the write to the database, and it will also be denied. So these two will have to wait until one of them gets off the database. So that's an example of deadlock. Another example of deadlock would be, let's say for a particular transaction, you need two pieces of data, A and B. And the two users, user 1 and the user 2, are both trying to perform the same action requiring these two pieces of data. So user 1 retrieves the record A first and puts a lock on record A. User 2 requests the record B first and puts a lock on record B. Okay, then user 1 requests record B and is denied, right? Because it's locked by user 2. And user 2 requests record A is also denied. because it's locked by user 1, right? So these two will wait until someone gets off the database. So that's also a situation of deadlock. Deadlock basically means nobody can do anything to the database until somebody gets off the database. So how do you resolve the deadlock situation? There are a couple of ways to resolve the deadlock. One is what's called a pessimistic approach. And the pessimistic approach means we are going to put an exclusive lock on all the records required at the beginning of the transaction. So in this case, user 1, when he or she starts the transaction, the system is going to lock both A and B at the beginning. So when user 2 tries to perform the same transaction, the user 2 will be denied. A performs the transaction and then will release the lock on both A and B, and then user 2 can perform the transaction. So that's called a pessimistic approach because it uses a lock to resolve the issue. The optimistic approach is something called versioning. And the versioning basically means we think that deadlock situation is infrequent. So what we are going to do is we are going to let the deadlock occur. Right? We're not going to prevent it from occurring. And instead of locking these records at the beginning of the transaction, we are just going to let these deadlock situations occur. And then once it occurs, we are going to resolve it on a case-by-case basis.